Okay, guys, apparently Tuesday in section, I didn't go over the Shapley-Shubik index for the final exam, problem 5. I went over the Bonjoff and the winning and minimal winning, so I did 5A, 5B, but I didn't do 5C. So I'm going to do 5C real quick, and I'm sending this email to the 4 guys that are always in class, because I feel like you guys really deserve this. So let's set it up. We have A, B, C, and D. 2 points for A, and then 1 each for B, C, and D. This is standard from the class. Can you guys see that? Yeah. Okay. Okay, never mind. The Shapley-Shubik index is on slide 209. That's what I have for mine. And the Shapley-Shubik is the Shapley-Shubik for any particular player is the frequency of times that player is pivotal for a particular coalition, and I'll explain that in a minute because it doesn't make sense abstractly without seeing it, over the number of possible permutations given a four possible parties. So this n factorial is different because when we're doing the Bonjoff index, if you have coalition A, B, C, D, that's all 4 parties. And that's the same under the Bonjoff, the same as like DCBA or any other variation of those 4 parties in any order. It's the same party. They're all 4 together. It's fine. Under Shapley-Shubik, however, we're only concerned with how many different ways we can order these 4 parties. So we're not going to think about party A and B, a coalition of A and B under Shapley-Shubik. We're only thinking of all the possible ways we can order A, B, C, D. So all 4. And when you have 4 things and you want to find the number of orders, you do the factorial of that number. So 4 factorial is 4 times 3 times 2 times 1, which is 24. So the Shapley-Shubik for A and the Shapley-Shubik for B, C, and D is going to be FA over 24, FB over 24, FC over 24, and FD over 24. Now the F thing is really important. So let's think about this because if you try to write out all the different permutations of A, B, C, and D, it's going to take you a long time. And oh shit, my bad. You might not even get them all. So just know that there's 24 of them, and if there are 24 possible permutations, we know that since we have 4 parties, that there will be 6 times each where A is the first one, 6 where B is the first one, 6 where C is the first one, 6 where D is the first one. So like A, B, C, and D. 6 times. 6, 12, 18, 24. And then we have to rearrange. I mean, if we were going to write them all out, we would find all the different ways we could organize B, C, and D in these blanks, right? So we know that there's 24, and that it's 6 per starting number. When we think about this, though, what the FI is asking us to do, the FI is saying, under all the possible permutations, let's see. So these are all the possible positions that A could take within any permutation of those 4 parties. And for S sub A, for instance, it says, how many times does A make the previous parties, the parties that preceded in that permutation, a winning coalition. So if we think about what's happening in this bottom section where A is last, the parties that precede it are going to be B, C, and D. Right? So B, C, and D, they each have 1 point. No matter what order we put B, C, and D in down here and make A last, the 3 parties preceding A are going to have a total of 3 points, making it a winning coalition because the majority of the 5 points is 3 points. So they're always going to have 3 points. So adding A to those 3 is not going to make it a winning coalition because it's already a winning coalition. So there, out of the 6 possible ways that we can order it so that A is the last one, because there are 6 ways that we can do that. None of them provide A any frequency points, right? So there's no instance where A makes those a winning coalition. If we look at this section right here, so A is the first in the permutation. And since there's nothing that comes before A, there's no way that A can make what precedes it a winning coalition because it's 0 that precedes it. And A only has 2. You need 3 to be a winning coalition. So out of these 6 times, never does A make it a winning coalition. So now let's look at this one. Remember, A has 2 points. Whatever goes here, it's either going to be B, C, or D, and each of those has 1 point. So no matter what goes here, it's going to be 1 point here, plus the 2 points for A, which makes it 3 points, regardless of who's here. So this is always going to be a winning coalition because we're adding 2 to 1. And there are 6 different ways that we can order A, B, C, D such that A is in the second place. So there are 6 frequency points, pivotality frequency points in this set. If we think about this set, A being third, there's 2 points here, and whatever's here, it's going to be B, C, or D. Same thing, B, C, or D here. It's going to be 1 and 2, right? So no matter what order they're in, A being third means that these 2 plus A equals 4, and that's more than a majority. So just these 2 by themselves it's only 2, not a majority. It's only 2 points. Adding 2 to that makes it 4, makes it a winning coalition. So there's 6 pivotality points here for A. So the frequency A is 12. Because out of the 24 times, the 24 possible permutations of A, B, C, D, 12 out of those 24 times, A is pivotal in making what precedes it a winning coalition. So 12 over 24 equals 1/2. Now, we can do the same thing with B, C, and D. I'm just going to do one of them because they're all going to do the exact same thing. And they all work out to 1/6, 1/6, 1/6. But it's helpful to see how and why that works out. So if we do B first, B second, B third, B fourth, there's 6 different ways, or 6 different ways we can do that one, 6 that one, 6 that one, 6 that one. If we think about B only having 1 point, it certainly doesn't make anything over here a winning coalition because it's 0 plus 1. None of those are going to happen. If we move to this one down here, since B's at the end, we know that A, C, and D are in here in some order. No matter what order they're in, it's going to equal 4. A, B, or A, C, D is 4, C, D, A is 4, whatever. It's 4. It's already a winning coalition. B doesn't make it a winning coalition. So none of those are pivotal. B is pivotal for none of those. If we move to this one, B has 1 point. The only possible way that B could be pivotal for what comes before it is if A comes before it, because A has 2. So 2 plus 1 is the only way we can make it a winning coalition. Because if C is here, it's 1 plus 1. If D is here, it's 1 plus 1. not a winning coalition. So we have to ask ourselves, how many different ways can we make B the second and A the first? Well, we can do A, B, C, D, or A, B, D, C. In both of those instances, B is pivotal for making A winning coalition. Now, if we do this one, 1 point, and then if we have A here or here, that means the other spot up here is going to be C or D, right? So it's either going to be 2-1 or 1-2. And in no instance here does B make this a winning coalition, because this is already winning coalition if A is up front. So the only way that B can make this a winning coalition is if A is over here, because then it's going to be CD BA or DC BA. So there's two instances here where B makes a winning coalition. So B's frequency is 4 out of 24. So 4 out of 24. And the exact same thing takes place for C and D. So 1/2, 1/6, 1/6, 1/6. These are the Shapley-Shubik indices, and they add up to 1. Because your Shapley-Shubiks, my office mate's flag, sorry. The Shapley-Shubik indices are always going to add up to 1, and the Bonjoff indices are always going to add up to 1. So in this, just because the Shapley-Shubik and the Bonjoff index in this example for this test are the same, you don't want to assume they're going to be the same on the test. You always want to calculate them to make sure. But you can assume that for Shapley-Shubik, once you figure out how A works, since A is the bigger party, you know that B, C, and D are going to split 1/2. Because B, C, and D have the same weight. They're each 1, right? So they're equally sharing in whatever power is left over. A has half of the power, so the other half of the power is split evenly between B, C, and D. So you can just do the math there and calculate your 1/6 for those. But personally, I think it's helpful to see how this works and to make it work so that it makes more sense. I encourage you to calculate this for C and for D. I showed you B. Do the same thing with C. Make sure you understand which variations provide pivotality frequency points for C and D. That way you can be confident in your calculations for the Shapley-Shubik index. Thank you guys for coming to class so frequently. I will see you either Thursday in my sections or Thursday in lecture, hopefully Thursday evening at the review session, but I'll email everyone if I get a room reservation. Great. Have a good night.